So in our previous video, we talked about the method we can use for polynomial division called synthetic division. So today we're going to we're going to use a little application of synthetic division in order to evaluate a polynomial. And this application is called the remainder theorem. And it basically says that if a polynomial p of x is divided by x minus c, then the remainder is p of c, okay? So what this means is if you were to plug the value of, if you want to evaluate a polynomial for some number, you can divide the polynomial by x minus that number. Now, in smaller polynomials, maybe degree 2 or degree 3, sometimes it's easier just to plug in the number. But when you get larger polynomials with higher degrees, this might be quite a bit faster to evaluate the polynomial, okay? But let's do a few simple examples here. So if we want to find p of 2, here in example 1 here, where we evaluate the polynomial at x equals 2, we could divide this polynomial. We can divide this polynomial by x minus 2. Okay, so we're going to do this using synthetic division. Okay, so if we want to divide this polynomial, x to the third minus 2x squared minus 8 divided by x minus 2, whatever our remainder is, according to the remainder theorem, is going to be the value of our polynomial at that point. Okay, so remember, if you're doing synthetic division, you want it to be in the form x minus r. It already is. So our r value is going to be 2. So let's go ahead and set this up. So 2, we'll do our division sign. And now we're going to plug in the coefficients. So we have a polynomial of degree 3, so we'll have 1 out front. Looks like we're negative 2. We don't have anything for the x term, so we're going to just go ahead and put a 0 there. And then we have negative 8. All right, so now let's go ahead and bring down this 1. So 2 times 1 is 2. And we get 0. Okay, so negative 2 plus 2 is 0. So 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. So we get negative 8 plus 0 is negative 8. So our quotient, okay, that's going to be a polynomial with these coefficients, which will be of 1 degree less. So it's going to be 1x squared, or just x squared, plus 0x plus 0 with a remainder of negative 8. So we'll just have x squared for our quotient. And our remainder is going to be negative 8. Okay, so that means that p of 2 is negative 8. And let's just confirm that this is right. So if we were to plug in 2 for p of x, so we'll do p of 2 is going to be 2 to the third minus 2 times 2 squared minus 8. 2 to the third is 8. Okay? And then we have 2 times 2 squared, or 2 times 4, which is 8. Okay? And then minus 8 again. So 8 minus 8 is 0. These cancel out, and we get minus 8 for our final answer. So this does in fact work. You can divide a polynomial by x minus whatever number you want to evaluate it at, and the remainder is going to be your answer. All right, so let's take a look at another one here. So we have f of x is equal to 2x to the fourth plus 5x third minus 2x minus 3, and we want to find f of negative 3. Okay, so f of negative 3. So we want to divide f of x. We want to divide that by x minus a negative 3. Okay, so therefore we're going to use synthetic division to do that. So we'll have negative 3 here, and now let's plug in our coefficients. So we'll have 2, we'll have 5, and we don't have anything for x squared here, so we're going to put a 0 there. Then we'll have negative 2 and negative 3. Let's go ahead and bring down the 2. So 2 times negative 3, that's negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 3 is positive 3, plus 0 is 3. 3 times negative 3 is negative 9. Negative 9 plus negative 2, that's negative 11. Negative 11 times negative 3, that's positive 33. Negative 3 plus 33 is going to be 30. So our remainder is 10. Or sorry, I don't know where I got that from. Our remainder is 30. And that's going to be equal to f of negative 3. And if you want to check that, you can. You can plug negative 3 in for f of x here. And anywhere you see an x, you plug a negative 3 in, and you should get 30 out for your final answer. Okay, let's try one more. So here we have q of x is equal to x to the fourth minus 4x to the third plus x minus 3. And we want to find q of 1. So we can just put our 1 right here. All right, we can plug in our coefficients, which are going to be 1, negative 4. We don't have anything for x squared, so we'll put a 0. We have a 1 for x, and we have negative 3. All right, so let's go ahead and bring down the 1. 1 times 1 is 1. 1 plus negative 4 is negative 3. Negative 3 times 1 is negative 3. 0 plus negative 3 is negative 3. And negative 3 times 1 again, that's going to be negative 3. 1 plus negative 3 is negative 2. And negative 2 times 1 is negative 2. And so then we're going to end up with a remainder of negative 5. And therefore, q of 1 is equal to negative 5. All right, so and what we're going to do is in a video that should be coming out soon, we are going to be using this technique to try and better understand polynomials a little further.